Hi all, this is the PSPICE simulation of RC transients. This is the second example. Please watch my first video on this. I have solved first example in that. My name is Prashant Kumar Suri and this is my email. So in this example, for the network shown in figure, this is the figure, the switch has been in position 2 for a long time. At time t equal to 0, switch is suddenly moved to position 1. Okay, initially the capacitor is uncharged before the switch is moved to position 1. Okay, and switch will remain in position 1 for 2 seconds, and after that it returns to position 2. That's what he has given. Okay, that means when the switch is in position 1 for 2 seconds, capacitor will charge, right? For 2 seconds, for the first 2 seconds, capacitor will charge through 30 kilo ohm resistor, and after 2 seconds the switch is in position 2. That means the supply voltage is cut off, so capacitor will discharge through 10 kilo ohm resistor. Please note it down. While charging, this is the path, and the time constant is R times C, right? 30 kilo ohm into 100 microfarad. For discharging, the switch is in position 2 and the discharge time constant is 100 microfarad times 10 kilo ohm, because the discharge resistor value is 10 kilo ohm. So he is asking calculate voltage across the capacitor at t equal to 2 seconds, and you have to sketch the graph using PSPICE. Okay. But in this circuit we need single pole double throw switch, because the switch is, for the first 2 seconds the switch is thrown to position 1, and from after 2 seconds the switch is moved to position 2. We require single pole double throw switch to simulate, but unfortunately PSPICE do not have single pole double pole switch. Okay, so you have to, PSPICE library has only single pole single throw switch. Either the switch is open switch or closed switch. So we need to modify this first. How you can modify? If you read the question carefully, it says the switch is in position 1 for first 2 seconds, right? That's what he says. That means for the first 2 seconds the circuit will be this. Okay, and that means the switch will be opened. Okay, I will use the open switch, single pole single throw switch, which opens at 2 seconds. Okay, and for the next 2 seconds the switch is moved to position 2. Okay, that means I am using here the closed single pole single throw switch, which closes at 2 seconds. Okay, so this is the thing which you have to use, because unfortunately PSPICE do not have single pole double throw switch. So we need to modify this before simulating this particular circuit. So this precaution you need to take. Okay, so I will solve this now using PSPICE. So let us go to PSPICE now. We'll search PSPICE Design Manager. Same procedure which I have explained in my first video on RC transients. Those who did not watch, please watch. Click schematics. Okay, so now we'll gather all the parts. As I mentioned you can go to get new part. Okay, I have explained in detail in my previous video. So we need VDC. Click OK, place and close. Next we need 2 resistors in the circuit, right? Type R, place and close. One resistor I will place it here, another resistor I will place it somewhere here. Okay, and we need to rotate it, this one. So you have to highlight it, you have to make it red color before rotating. go to edit, rotate, and I will drag and place it somewhere here. Okay, and now we need one capacitor, so get new part, capacitor, place and close. Okay, so this also I want to rotate it, make it right, make it red color, edit, rotate, and we'll bring it here. Okay, now we have to make use of two switches, because one single pole single throw switch for the charging part, which opens at 2 seconds, and another single pole single throw switch which close in the discharging path, which closes at 2 seconds for this particular problem, right? So get new part, libraries. As I mentioned in my previous video, switches can be found in eval. Okay, so we need open switch one. Okay, this is the open switch, SW_T open, click OK, place and close. Okay, and another switch we need, closed one. Okay, so go to libraries, go to eval, close switch, SW_T close. Okay, place and close. So we'll place somewhere here. Okay, and we also need analog ground, draw. So get new part, libraries, analog ground can be found in port. So you have to select AGND, means analog ground. Okay, place and close. We'll place it somewhere here. Okay, now we have to wire it. So this is the, click it here, draw wire. Okay, connect all these parts. Okay, so we'll connect it. Okay, so we need to connect the capacitor as well. Capacitor, right? So we have rigged up the circuit in PSPICE. Now we have to give the values. The voltage value is given as 40 volts. As I mentioned in my previous video, you can just type 40 or 40V. V stands for voltage. Save attributes. Okay, and R1 charging resistor value is given as 30K. Go to value, click it, 30K. Save attributes. Okay, and the switch in the charging path, that means switch is moved to position 2 after 2 seconds. That means the switch in the charging path must open at 2 seconds. So you click T open here, it should open at 2 seconds. So just type 2 or 2S. S stands for second. Okay, both are okay. So save attribute. Okay, now capacitor value given in this question is 100 microfarad. 100 micro is denoted as U. Save attribute. As I mentioned in my previous video, you must mention the initial conditions, okay, of the energy storing element. Here only one energy storing element, that is capacitor. Initially it is uncharged, so it is 0 volts. You can type 0V or simply 0. For more details, please watch my previous video. So next, this switch is closed at 2 seconds. Click this, double click this, click T close. So it should close at 2 seconds. You can type 2 or 2S. S stands for seconds. Save attributes. Okay. Discharging resistor value is 10K. 10K. Click OK. Okay. Now he is asking you to plot the voltage across the capacitor. So click the voltage marker and place it across the capacitor. Okay. So that means it is measuring the voltage at this point with respect to the ground. Okay. So I will zoom out. I'll zoom this area so that you can clearly see this. Okay, so this is the complete circuit we have rigged up. Now, as I mentioned in the previous video, you have to set up the analysis. We need the transient analysis. So click analysis, click setup. We need the transient analysis. Okay, transient. Okay, so I will set up from 0 to 4 seconds is asked, right, in the question to plot the graph. So 0 to 4, click OK, close. Now we have to save this. That is the next step. Those who are new to this video, please watch my previous video. This will be transient second example. Okay, click save. Now you have to simulate. So either you can go to analysis or click this simulate, or directly there is an icon here, simulate. You can start simulating. Okay, so it will go to the probe. This is the probe. So this is the voltage across the capacitor. As you can see here, for the first 2 seconds, capacitor will charge from the source through 30 kilo ohm resistor, and for the next 2 seconds the switch is moved to position 2. Okay, that means capacitor is discharging through 10 kilo ohm resistor, right? So he is asking you to plot the graph of voltage across the capacitor for the first 4 seconds. This is the first part of the question. Second part of the, and in the same question is asking what is the capacitor voltage at t equal to 2 seconds, right? So what you have to do, please watch my previous video. I am explained this kind of situation. You need to click trace, take the cursor first, display, click display. Okay, and now you click the, you move the right arrow in your laptop till if you look A1 equal to, first part is your x-axis is time. Second part here is the y-axis value, that is the voltage. Okay, so t equal to 2 seconds is here. So you can see here t equal to 2 seconds, and the capacitor voltage is 19.294. 19.294 volts is the capacitor voltage. You can mark this point. That is the first part of the question. Marker is here. Okay. Second part of the question is you have to find the time interval where it reaches 10 volts for the first time. First time 10 volts it will reach during the charging cycle. 10 volts is, move the cursor. 10 volts is somewhere here. So this is approximately 10 volts. Okay, this is the first time. It takes around 868.056 milliseconds. Okay, so that is approximately it is 0.87 seconds. Okay, for the first time. Then for the second time 10 volts it reaches during the discharging cycle. So that is this point. Okay, take the cursor here. See, this is exactly 10 volts. Okay, it takes around 2.67 seconds. 2.67 seconds. So he's asking you to find the time interval between these two. So probably I can go to plot. Okay, level, I'll take the arrow. So he's asking you to find the time interval between these 2 points. These 2 points. Okay, so that means you have to sub 2.67 minus 0.87. Okay, so 2.67 minus 0.87 will be 1.8 seconds is the answer. So I'll go to plot label text. So this will be 2.67 minus 0.87 equals, so 1.8 seconds is the answer. Okay, so you will place it here. Okay, so this is how we need to simulate whenever the transient circuit requires single pole double throw switch. Okay, so as I mentioned you, PSPICE do not have the single pole double throw switch. It has only, PSPICE library has only single pole single throw switch. Okay, and which requires the modification of the circuit. Modification of the circuit is by using two single pole single throw switches. I hope you have understood this video, and thank you very much for watching.